Elon Musk just got offered a compensation package that could make him the world's first trillionaire, but only if he produces 2 million robots and grows Tesla's market value to $2 trillion. Meanwhile, OpenAI is about to premiere an AI-generated animated film at Cannes that cost $30 million and took 9 months to make, while traditional animations cost $200 million and take years. We're witnessing a fundamental shift where the biggest tech companies are betting their futures not on better software, but on physical robots and AI-generated content that could replace entire industries. Let's start with Musk's unprecedented compensation deal, because the specifics reveal Tesla's strategic direction. To become a trillionaire, Musk must produce 1 million Axie robots and 1 million Optimus humanoid robots, grow Tesla's market cap to $2 trillion, and deliver 200 million vehicles. For context, Tesla delivered under 2 million vehicles last year, so we're talking about a 100x growth in vehicle production. The kicker is that Musk believes humanoid robots will eventually represent 80% of Tesla's value. He's essentially saying that Tesla's future isn't as a car company, but as a robotics company that happens to make cars. The initial price point for Optimus is projected at $200,000, with costs decreasing as production scales to millions. Now, I'm skeptical of these numbers for several reasons. First, Tesla has a history of optimistic timelines that rarely pan out as promised. Second, the technical challenges of mass-producing reliable humanoid robots are enormous. But here's what's interesting. Tesla has proven they can scale manufacturing and reduce costs dramatically. The Model S started at over $100,000, and Tesla eventually produced Model 3s at $35,000. If they can apply similar cost reduction to robotics, the economics could work. While Tesla focuses on humanoid robots, other companies are solving more immediate problems. UCLA, Google DeepMind, and Alphabet's Intrinsic have developed Robot, an AI algorithm that coordinates fleets of robotic arms like a ballet performance. The results are impressive. 8 robotic arms can plan and execute 40 tasks in seconds after just a few days of training. This reduces factory planning time from hundreds of hours to seconds. For automotive, electronics assembly, and construction, this could save enormous amounts of time and cost. This represents a more realistic near-term application of robotics. Instead of trying to build general-purpose humanoids, they're optimizing specialized robots for specific industrial tasks. X-Square Robotics, backed by Alibaba, is taking yet another approach with their $100 million investment. Their Wall OS robot can replicate written text using scattered letters, and their Quanta X2 humanoid has wheels and is designed specifically for household cleaning tasks. X-Square predicts household cleaning robots could be practical within 5 years at a $10,000 price point. This seems more achievable than Tesla's broader humanoid robot vision, but it's still a specialized application rather than general-purpose robotics. Now, let's talk about something that sounds like science fiction, but is apparently real: MIT's Alterego device. This wearable technology detects small muscle movements in your jaw and throat to convert intended speech into digital signals. Users can think what they want to say, and it's transmitted directly to another user's device without speaking aloud. It works in noisy environments and supports real-time translation between languages. The device requires no surgery or brain implants. If these claims are accurate, the implications are staggering for people with ALS, paralysis, or other conditions that affect speech. The technology could also revolutionize communication in environments where speaking isn't practical or possible. But I want to be clear about my skepticism here. The claims sound almost too good to be true. Reliably detecting intended speech from subtle muscle movements would require incredible precision and training. While the basic technology for detecting muscle activity exists, the leap to accurate speech recognition seems substantial. OpenAI's Critterz animated film represents a potentially seismic shift for the entertainment industry. With a $30 million budget and 9-month production timeline, it demonstrates dramatic cost and time reductions compared to traditional animation. The production process involved 3 years of character development, starting with OpenAI's text-to-image generators, then using GPT-5 and video generation models. The budget primarily covered computing power, voice acting, and tool usage, rather than large human teams. Early reviews suggest the emotional quality matches Disney and Pixar productions. If audiences connect with AI-generated content at the same level as traditional animation, it could fundamentally disrupt Hollywood's economic model. The cost implications are staggering. If AI can produce similar quality content at 15 to 20% of traditional costs, it creates competitive pressure that could reshape the entire industry. However, there are significant challenges. Copyright issues are already emerging, with Warner Bros. Suing Midjourney for generating Superman and Batman characters. Anthropic faced similar lawsuits and agreed to pay fees for training on copyrighted works. The legal framework for AI-generated content using copyrighted training data is still evolving, and this uncertainty could complicate commercial deployment. OpenAI's partnership with Broadcom and TSMC to design custom AI chips represents another strategic shift. By 2026, OpenAI plans to produce its own chips with a potential $10 billion order from Broadcom. This follows a pattern we've seen with Apple, Amazon, and Google, major tech companies developing custom silicon to reduce dependence on NVIDIA and control their infrastructure costs. The move makes economic sense given the scale of AI computation required, but it also represents a massive capital commitment and technical risk. Chip design is notoriously difficult, and even successful companies often struggle with their first-generation custom silicon. DeepSeek is expected to release a new agent AI model in Q4 that can perform multi-step tasks autonomously. This represents evolution from AI systems that answer questions to AI systems that take action. Google's embedding Gemma takes a different approach, bringing AI capabilities directly to consumer devices without internet connectivity. This enables real-time responses while keeping sensitive data private and reducing dependence on cloud infrastructure. The trend toward on-device AI addresses both privacy concerns and latency issues, but it also requires significant advances in efficiency to run sophisticated models on resource-constrained hardware. If you like this video, don't forget to hit the like button, comment with your thoughts on whether robots or AI content will transform industries faster, and subscribe to the channel for more emerging tech analysis. Microsoft's reported consideration of using Anthropic's Claude models instead of OpenAI's, even in Office applications, reveals how quickly partnerships can shift in the AI space. Claude's ability to directly edit Excel, Word, and PowerPoint files through chat commands represents a more integrated user experience. These corporate strategy changes highlight how rapidly the competitive landscape is evolving. Companies that seem to have stable partnerships are reconsidering relationships based on capability differences. OpenAI's $500 billion valuation, reflected in their $10.3 billion employee stock sale, represents extraordinary market confidence in AI's potential. But valuations this high create enormous pressure to deliver transformative results. The gap between current AI capabilities and the revolutionary applications needed to justify these valuations remains substantial. While the technology is impressive, the practical deployment challenges are often underestimated. Looking at all these developments together, several patterns emerge. First, the timelines are consistently aggressive. Whether it's Tesla's robot production targets, OpenAI's chip development schedule, or various companies' AI deployment plans. Second, the technical challenges are often more complex than initial projections suggest. Humanoid robots, custom chip design, and reliable AI agents all involve substantial engineering hurdles. Third, the economic incentives are driving rapid investment and development, but market pressures may lead to premature deployment of technologies that aren't fully ready. Based on historical technology adoption patterns, I expect we'll see gradual progress rather than revolutionary transformation. Industrial robotics applications will likely succeed before general-purpose humanoids. AI-generated content will find niche applications before replacing major studios. The chip independence movement will probably succeed for companies with sufficient scale and expertise, but smaller players may struggle with the complexity and cost. AI agents will become more capable, but reliable autonomous operation in complex environments will take longer than current projections suggest. We're clearly in the early stages of major technological shifts in robotics, AI content generation, and chip design. The scale of investment and corporate commitment suggests these aren't temporary trends. However, the timelines and performance claims often seem optimistic compared to the technical realities. The gap between laboratory demonstrations and reliable commercial deployment typically takes longer than initial projections. The trillion-dollar compensation packages and billion-dollar valuations create enormous pressure for rapid results, which could lead to either breakthrough innovations or spectacular failures. What's certain is that these technologies will continue advancing, and the companies that can successfully navigate the transition from prototype to scalable deployment will reshape multiple industries. The question isn't whether AI and robotics will transform the economy, but how quickly and which specific applications will prove most viable. The next few years will separate genuine breakthroughs from overhyped promises. Whether Musk becomes a trillionaire from robots, OpenAI disrupts Hollywood with AI films, or custom chips enable new AI capabilities, the broader trajectory toward more capable, more autonomous technology seems inevitable. The challenge for investors, workers, and society is preparing for changes that could happen faster than expected while maintaining realistic expectations about what's actually possible in the near term.